All right, I just wanted to address some of the major problems on the last quiz. And so inside the Google Drive, you will see this document. Go ahead and grab it. And if you want to, you don't have to, and work along with me. P of x is a polynomial. It is differentiable, and its derivative exists everywhere. So the critical points of P of x will be where P prime of x is 0 in the domain. So P prime of x is 3x squared over 3 plus 2x minus 15, which is x squared plus 2x minus 15, which is x minus and x plus, and I think it's 3 times 5, and it has to be this way. Okay, P prime of x will be 0 if and only if x is 3 or x is minus 5. Okay, now the way I see this, this polynomial, if you think about it, its zeros are at 3 and at negative 5, and it does this. So P prime of x, and I can quickly, if I remember that from Algebra 2, if I don't, then I have to go test everything. So assigning the signs from the little graph. So what's P of x doing? It's increasing on negative infinity to negative 5 open interval, or from open interval 3 to positive infinity, it's increasing. And it's decreasing from minus 5 to 3 open interval. All right. Now, you know a couple things. I didn't ask you, but you can talk about local extrema if I was to ask, but that was not the intention here. So P of x is increasing on minus infinity to minus 5 or 3 to infinity, because P prime of x is positive on minus infinity to minus 5 or 3 to infinity. The next sentence I would have written, I should have given myself more room, is P of x is decreasing on the open interval from minus 5 to 3 because P prime of x is negative on minus 5 to 3 open interval. The critical points of P prime are where P double prime, so I need the second derivative. Let me see, I believe that's going to be 2x plus 2. P double prime exists everywhere. P double prime of x is 0 if x is minus 1. So I make my number line chart at negative 1. It looks to me that if I put anything that's greater than negative 1 in there, I get a positive. Anything is negative. So I know that P prime is decreasing from minus infinity to minus 1 and increasing thereafter. And I leave the sentences to you. The last part of this question was, what does your answer, what does this answer tell you? It tells you a couple things. Number one, it tells you where P of x is concave up and concave down. But it also tells you that at x equals negative 1, P prime has a local minimum, because at x equals 1 for P of x, we have a point of inflection. Because P double prime of 1 is 0, and P double prime changes signs about this value. X equals, I think that was negative 1, right? And don't let me write that wrong. The next sentence I'm going to write is P prime of minus 1 is a, and I look at my local minimum by the first derivative test, because P prime of negative 1 is 0, and P double prime P double prime of negative 1 is 0, sorry. And P double prime changes signs about x equals minus 1 from negative to positive. And that was the best response you could have.